Hello everyone. So previously we had discussed on the topic job scheduling algorithm, which basically uses the greedy approach itself, right? So now we are discussing this one greedy based algorithms itself. Yeah. So now let's discuss one of the famous algorithms actually, Huffman coding algorithm. Yeah. So let's get into the definition part. Let's see what the definition part says here. So Huffman coding is a lossless data compression algorithm that assigns variable length, this one variable length binary codes just to the characters based on the frequencies. We have made use of the Huffman coding one previously as well. If you remember, we have discussed this one while discussing in the JavaScript as well. So now the programming language differs and we will be going in much detail. Other than that, we have already discussed. We have the idea on this. If you have followed every video of mine that I have this one actually uploaded. If you haven't, now you can. This is fine. Yeah. So Huffman coding is a lossless data compression algorithm that assigns variable length binary codes just to the characters, this one, to the characters based on their frequencies, to the characters based on what? Based on their frequencies. You have to remember this. This is important. Yeah. So now characters occurring more frequently get shorter codes. Yeah, characters occurring more frequently. Yep. So what they get the shorter codes, while rare characters get longer codes. While rare characters get the longer codes, right? Minimizing the overall encoded size. Minimizing the overall encoded size. Yeah. So let's move on with the explanation part here. So Huffman coding works in four main steps. So this four steps, whatever we discussed, the exact same thing will be implementing or articulating in the form of code. Just listen to this carefully. Yeah. Now the first step here would be counting frequencies. First, what we'll do, we'll count the frequencies of the characters, right? So we will determine how often each character appears in the input. Again, we will determine how often each character appears in the input. So this is the first step. Then what we'll do, we'll build a min heap. So we'll be making use of the priority queue within the Huffman coding algo. Just remember this one. Huffman coding, this one basically involves priority queue or the min heap or minimum priority queue. We can just call this one. Yeah. So we will build a min heap or the priority queue. Yep. Each character becomes a leaf node with its this one frequency as weight. Frequency will be considered as weight. Just remember this one. So we will be building a minimum heap. Or the minimum priority queue we can consider, each character becomes a leaf node with its frequency as weight. Yeah, simple. Let's move on with the third step here. So we will build the Huffman tree. When I say we will build the Huffman tree, we repeatedly extract two smallest nodes. Yeah, so we repeatedly extract two smallest nodes and will combine them. So again, so we'll build Huffman tree, will repeatedly extract two smallest nodes and will combine them into one with the sum of their frequencies, and finally we will reinsert until one node remains. I wanted to tell this one actually was not this one was not present. Actually, this is one of the important steps we shouldn't miss. Yeah. So this then after building this one, each character becomes a leaf node with its frequency as weight. We know this. After that, we will build the Huffman tree, right? So we'll repeatedly extract two smallest nodes first. Yeah, two smallest nodes, combine them into the one. Combine them into the this one. Combining them into the one actually with some of their frequencies, some of their frequency. Each character have will be having the different frequency, right? So we'll combine their frequencies, and then what we'll do, we'll reinsert until one node remains. We'll reinsert until only single node, uh, until single node remaining actually. Yeah, this is fine. Finally, we'll generate the codes. Generate the codes means we'll traverse the tree to assign binary codes. We will be traversing the tree just to assign the binary codes. Yeah, 0 for the left branch and 1 for the right branch. Yep, just remember this one. We'll be traversing the tree to assign the binary codes. 0 for the left branch, 1 for the right branch. Simple. Now the result is an optimal prefix free binary coding. The result is the optimal prefix free binary encoding. Sorry, not coding, encoding. Yep. So now the exact same thing from here to here. Let's try to implement or articulate in the form of code. Let's start writing the algo. Yeah. So for implementing, we'll be making use of the minimum heap or the min priority queue. We have already discussed this one in the explanation part. So let me import here uh, heap queue actually. Uh, so this is fine. Now we also need the default dictionary here. I'll just go with from collections. So let me go with import default dict. So this is fine. Yep. Now let's move on with the first step. We have to define the class for the Huffman tree node. So let me go with the class node here. So this is fine. Class node. Yep. So this is fine. So within the node class, first let me go with the initialization or the constructor part. So this will be if I'll just go with the init. So init is not showing. Yep. Let me go with the init. Let me delete this along with the self. I need this one character as well as the frequency, right? So I'll just go with the char and freq for the frequency. This is fine. Within the initialization part, I'll just go with self.char. Let me initialize this one to character A, B, C, right? So that one we are considering. Next, let's go with the frequency of that particular character. Just go with FREQ. Let me initialize this one to the frequency. This is, sorry, what happened here? So this is fine. I forget that I'm coding in Python actually sometimes. So this is fine. Self dot this one frequency. Let me assign this one to the FREQ. So this is fine. Next, let's go with the left child as well as the right child. Right. So I'll just go with left and let me go with right here. Let me assign this one to the so we have to assign this one to this one to the none, right? And right to none initially initializing this one at the none. Yep, this is fine. Now let's move on with the next step or the further step. So we have to define the comparison operator for heap queue. So I'll just go with def this one. Let me go with a what do we call? Let me go with a comparison operator. We have to make this up, right? So I'll just go with LP here. So let me go with LP. I'm just getting a call. Just give me a second here. So let me go with some this one random name here. So this is fine. I'll just consider here self along with the other. So this is fine. So within this method, so let me return mm, frequency if it is less than other dot frequency. Yeah. So this is fine. Let's move on with the main function. Now, this is just the function to generate the Huffman codes actually. Let me go with def here. So let me go with the Huffman, sorry, Huffman encoding. So I'll just go with encoding. So this is fine. Let me pass the text here. So this is fine. So let's go with the edge case if the text is empty, right? So I'll just go with if not text, then let me return something, man. Yeah, let me return here. This is fine. So this is also fine. Let me move on with the fourth step here. Nothing but we have to count the frequency of each character. So I'll just go with frequency equals default dict. So this is fine. Let me pass the int. Yeah. Now let me go with for ch and text. So here within this, let me go with frequency of the character. We have to increment this one, right? Frequency of character plus one actually. So this is fine. So why this is screaming here? Text is not defined, not in text. So we have called text here. What's wrong here? So here I have considered uncoding. Have considered text here. This one Huffman encoding of text itself. I have passed the parameter. This is fine. Why this is giving us not defined actually? If not text, then we are returning just this one empty string. So this is fine. If text is empty, suppose this is one of the edge cases. This is fine. Frequency, I'm just assigning this one to the default dict and we are passing int. So this is also fine. We are just counting the frequency of each character, right? So for character, this one ch in the text. So this has to be, eh? Why this is showing, man? We have Huffman encoding is not accessed. Why? So basically this might be this one actually. do you call? Oh yeah, this one what do you call indentation problem. Let me do one thing. Let me move this one to here. So within the if, let me move this one to here. So this is fine. Yeah. Now frequency. Let's move this one to this one along with the if condition. So for loop has to be same. Again, the frequency part. Let's move with the this one return. So this is fine. I believe. 1 second. Just give me a second here. So this is fine. Now let's do one thing. Yeah, indentation. That was the indentation problem actually. Now this is fine. Mm, let's do one thing. We have made use of the heap, right? So I'll just assign this one heap the node of what are the things we have to pass character, individual character along with the FR. So this is fine. Yep, frequency for character, comma, FRN frequency dot items actually. This one I'll just consider FREQ dot items. So this is fine. Yep, this is fine, man. Yep, let me do one thing. I'll just go with a heap queue dot. Let me make use of the heapify. So yeah, this is heapify of. Let me pass heap one. So this one heap. So this is fine. Let's move on with the step 6, nothing but we have to build the Huffman tree, right? So I'll just go with a while of uh this one length of this one heap. If it is greater than 1, then what we'll be doing here? Let's extract the smallest, let's extract the next smallest, let's merge the nodes, and also let's this one. Finally, let's push back merge node. These 4 things we have to do. First, let's extract the smallest as well as the next smallest. So this one will be left equals heap q, or I'll just make use of the heap pop here. So this is fine. Heap pop of, let me pass the heap here. So this is fine. Yep. So now let me go with the right and let me assign this one to the again heap queue. So this is fine. Dot heap pop. So this is fine. Let me pass the heap. So this is fine as well. Let me go with merged. So this is node of. So first initially let me go with none left dot frequency plus right dot frequency. This is fine. We are just merging the nodes. So I'll just go with a merged dot left. Let me assign this one to the left as well as merged right. So let me assign this one to the right. So this is also fine. The final one here would be, let's push back this one merged node actually. I'll just make use of the heap cube. This is fine. Dot heap push. So let me make use of the heap push here. So what we have to pass here, one thing is heap along with the this one merged variable. This is fine, man. So we are only left with certain things actually. Now we have to generate the binary codes using the recursion, right? So we have to generate this one. What do we call? Binary codes using the recursion. So let me write here root equals heap of 0. This is fine, and also codes equals. So this is fine. Yep. Now let's do one thing. Let's go with the generate codes. So I'll just go with the generate codes. Yeah. So this one is fine. Node, comma, current code. Yeah. So this one is fine. Node, comma, current code. So within the generate codes function actually, uh, if node, if node is none, if node is what do we call? Let me go with none. If node is none, so let me hit the return here. Hit return. Then let me go with one more if condition here. If node dot char is not found actually, not found, if not none actually, sorry. So this one has to be If you are not none, let me select this one. So then what I have to do, we have made use of the codes actually. Codes of node.character. So let me assign this one to the current code. Yep. So finally, let's return. We have to exit, so I'll just give return here. Then let's make use of the this one. What do we call? Let's recurse here. I'll just go with generate codes here. So this is fine. So let me go with node.left and current code, along with the this one. What do we call? Let's append 0. Let's concatenate 0 here. This is fine. Again, let's go with the this one. Let's recurse again. So this time we have to do it for the right one as well, right? Right child as well. So I'll just go with a node dot write. So let me type this one entirely. So the same thing, current node, sorry, current code plus instead of concatenating or appending this one 0, we'll append 1 this time for the right side. So this one. This is fine, man. So after this, let's do one thing. We have to start. So let me give here. So I have to start from here, I believe. Yeah, along with the function. So I'll just call the function here, generate codes along with calling the function. Let's start from the root. Initially, it will be empty. Yep. So this is fine. Now let's move on with the last step. Last step, nothing but I'll just go with the encoded text here. Uh, mm, let's give here. Let's make use of dot join. So this is fine. Let me go with codes of ch. So this is fine for individual character ch in text. So this is also fine. Let me return here this one actually codes as well as let me pass the encoded text. So this one will be encoded text. So this is fine, man. So finally, what we'll do, we have to test the Huffman coding, nothing but. So we'll be going with the example you said. So we have where this one, we have successfully written the algorithm here until here, right? So this is fine. Yep, I have explained this one step by step. Now let's move on with the example you said. Let me take this one from the Google. Just give me a second here. So let me paste it over here. This is fine. Yep, I have just considered the text Huffman here. So also we are just going with we are just testing the Huffman coding here. I'm just going with the codes and the encoded text. We are just calling the Huffman coding this one. What do we call? Uh, Class actually. Sorry, function. This one, main Huffman coding function. Yeah, we are just passing the text Huffman here with the string Huffman. Yeah. Now we are just making use of the print just for the interactive purpose. One is character codes and we are passing the codes, and encoded text we are passing the encoded text here. This is fine. So now if I run the code, we have the idea on the this one algo, I believe. So let me explain this one so that we don't forget. So let me explain this one very quickly. So import heap queue. So this is used to implement the minimum heap, right? So this is the efficient way. So this is fine. So next from collections import default tick. So this one we have to count the frequencies, right? So for counting the frequencies easily, we'll be making use of the default tick. This is fine. Next we are going with a class node here. So what it does basically, it represents a node in the Huffman tree with a character, also along with the character frequency, and then left and right children, left or right children. Yep. So this is fine. Next, this one LT, whatever I have written, this part. So what it does actually, this defines how many nodes are compared, right? So it is completely based on the frequency inside heap queue. This is fine, man. Now we are going with the Huffman coding of text. So whatever function name I have written. So this is the main function here, right? So that performs the entire Huffman process. Yeah. Frequency of character, this one equals +1 I have given here, but on the line number 40, in the line number 40, so this one counts the frequency of each character. Heap, we have made use of this one node of something character for the individual frequency FRF pass. So this one actually what it does, it creates the node for each character and makes a heap. This one we know. Yeah, now let's move on with the while loop one. This one while length of heap greater than 1. So this one will continue merging until one tree remains basically. merged equals something we have written here. Basically node of none left dot frequency plus this one right dot frequency. So this is nothing but we are creating a new parent, this one node for the combined frequencies. Then we are recursing here. Then we are recursing here. Generate codes of this one. Sorry, not recursing. This one we are calling the function, and we are starting from the root actually. So we are recursively assigning the binary codes here. 0 equals left and 1 equals right. So we are recursing itself in simple terms. But yeah, we are recursively assigning binary codes, nothing but 0 to the left child and 1 to the right child. Yeah. Finally, we are going with the encoded text. This is nothing but we are building the encoded binary string, and this one. We are just finally printing the character codes and the encoded text here within the example. This one, what we call example usage. Yeah, that's what we are doing. Now, what is the output that we need to get actually? So let's discuss the output part. We have complete understanding of the algorithm now. So the output, basically input, we are going with the this one, Huffman actually. Input, we are going with the Huffman. Yeah. So input, we are just going with the Huffman. This part. Yeah. Text, we are considering Huffman, and the output that we need to get here is this one. We have to get the character codes, right? So encoded text. So basically this one. Sorry. Character codes. So let me write in this way. Character codes. What are the character codes? H. So basically this one will be this one. This will be 00 actually, and u, so this one will be actually 01, so this will be encoded as 01, and f will be encoded as 10 here. F will be encoded as 10, and m will be encoded as this one, 110. So this is fine, 110, and a will be encoded as this one, what do we call, 111. Yeah. So this is it for the this one, Huffman, this one, what do we call, character codes, right? Character codes, we have to get the output this one. Yeah. So individual character will be encoded here. 00 u2 this one. uh f, so again we have f, so I have shown you the single f, 10, and m, hu double f m a n, right? So this is fine. M we have encoded to 10 here, and finally a, we are encoding this one to the 111. So overall encoded text actually we have to get 00, 1 actually, 001. uh, Again we have 01. We are going with the Huffman, right? Encoded text has to be 0010. Again this one 10 actually, 001010. So this time it will be 110, this one, 111. Actually, this is the encoded text that we have to get basically. Yeah. So this one. Second print statement. First print statement, we have to get this one. Actually, we are going with the text Huffman. So first character codes, we have to get this one, and the encoded text, we have to get this one. Yeah. Let's check the same actually. Hope now the this one. Whatever the output that we get, this one we have to get actually. That part is completely clear, man. Accordingly with the input that we have considered. Yeah. So we know this one. So let me copy this one. Let me come here. Let me give Control J. So let me give Python followed by filename.py. We have some error here. Not supported between the instances of node and node. Line number 43. What's wrong here? Hmm? 1 second. So this is within the Huffman coding, right? So this is within the Huffman coding. So what we are doing here, this is fine. Number 43. Heapify of heap. So this is fine. Node of character comma frequency. This is fine. Frequency dot items, I have passed the parenthesis. That is also fine. Then what is wrong, man? FR in frequency dot items. So this is also fine. Let's check what is wrong actually. So what mistakes I have done here is, so here basically the indentation problem actually. So let me give here, let me move this one to this one. This is fine. Now this has to work. Mm, the line number 48, see here, I have passed here node instead of the none. Initially it has to be none, right? So this has to be none actually. This is fine now. Yeah, now this shows in a different color. This is fine. Next, let me go to the line number 57. Here, node n has to be small here. N has to be small. This node, yeah. Yep. Now this has to be correct actually. Let's see. Let's check the same. Skip clear screen. Run this one. Yeah. See. Now we are getting the character codes U00, F01, and this one. N100, H101, A110, and M this one. Yeah. So whatever I have showed, that is also correct. Character codes, right? Character codes might differ during the encoding process. So that is also correct. Encoded text will be the same actually. Encoded text will be the same actually, I believe. Yeah. So this one will be 1 second. Encoded text might also differ, right? So let's do one thing. Yeah. So this one we can have the multiple outputs for this one. We can have the multiple outputs. So this is also encoded text. So this one is also correct actually. So the output that I thought, so basically by this one, accordingly with the what code I have written, so I might get that output as well. So this is one of the correct output as well. Multiple outputs we can get. So this is fine as well. So yeah, here basically Huffman code tree. So this one doesn't, this one, what do we call? It doesn't guarantee one unique, this one code assignment, right? So we can have the multiple output. So uh, this is also correct. Whatever the output that I explained, that is also correct. This is one of the I explained one of the valid outputs accordingly. So this is also correct actually. The same way. Yeah. So this is fine, man. So we are done with the Huffman coding, this one algorithm. So this is it for the algo. We are getting the desired output, right? So this is fine. Let's do one thing. Now, as we are completely familiar with the algo, as we're done with the algorithm, basically, let me summarize whatever we have learned so far before hopping into the next algo, right? So now let me tell you, or let me summarize, or just try to remember these 3 to 4 points, man. This is fine. Yeah. Yep. The first point here is Huffman coding reduces the data size. It reduces the data size basically, right? So this reduces the data size using variable length binary codes, using variable length binary codes. So this is fine. So the next step would be it uses minimum heap, right? It uses minimum heap to build an optimal prefix, this one, optimal prefix free binary tree. It uses minimum heap or the minimum priority queue. Yeah. Now the most frequent characters get shorter codes. So this one we have already discussed. Most frequent characters get this one shorter codes, and this one optimizing the compression, and this yeah, the most frequent characters get the shorter codes, optimizing the compression. Yeah. And the final one here is it's widely used in file compression tools, right? So whatever you compress, so whether it may be to the zip or whether it may be this one jpeg, right? So it is widely used in the file compression tools, uh, zip files. So this one jpeg, jpeg. Yeah. So it is widely used in the file compression tool. So this is the use case actually. Yeah. So this is the use case you need to know. So these are some of the points that I wanted to discuss. This is important. Yeah. So we are done with the Huffman coding algorithm. Yep. Next, what we'll be doing, we'll be discussing on the topic minimum spanning tree algorithm. Basically, this uses priority queue along with the greedy. So I wanted to discuss this one. Now we'll be discussing this one. Next, we'll be discussing minimum spanning tree algorithm. Yeah. So we are done with this algorithm. For now, this is it. Thanks for watching, guys.